all people did not know about the space. In space, no one can hear you scream. We've all seen the classic Hollywood sci-fi blockbusters. A massive star destroyer explodes in a fiery roar. Laser cannons fire with a satisfying pew-pew. An astronaut's thrusters hiss as they navigate the void. It's dramatic, it's exciting, and it's completely wrong. If you were actually standing right next to a detonating spaceship in the middle of deep space, you wouldn't hear a single thing. Not a bang, not a hiss, not even a whisper. The famous tagline from the 1979 film Alien got it right. In space, no one can hear you scream. But why is this the case? Why does the universe strip away our ability to hear? Is space truly completely silent, or are we just tuning into the wrong frequency? To understand why space is a silent void, we have to look at the fundamental physics of sound, the reality of the cosmic vacuum, and the surprising, eerie exceptions where the universe actually does have a voice. What is sound, anyway? To understand why sound dies in space, we first have to understand what sound actually is. Sound isn't an independent entity that just floats around waiting to be captured. It is a mechanical wave specifically, a pressure wave. Think about what happens when you speak. Your vocal cords vibrate, physically pushing against the air molecules closest to your throat. Those molecules bump into the next group of molecules, which bump into the next, creating a domino effect of high pressure and low pressure zones traveling through the air. This is what we call a longitudinal wave. For sound to travel from point A to point B, it requires a medium. It needs a crowd of physical particles to pass the vibration along. In a solid material like steel, atoms are packed tightly together. Because they are so close, they can pass vibrations incredibly fast at about 5,000 meters per second. In liquids like water, the atoms are slightly looser, but still close enough to carry sound at roughly 1,500 meters per second. In gases, like the air we breathe, the molecules are bouncing around with plenty of space in between, allowing sound to travel at a leisurely 343 meters per second. But what happens when you remove the medium entirely? Imagine a stadium wave where tens of thousands of sports fans stand up and sit down in sequence to create a massive ripple around the arena. Now, imagine that same stadium but only 3 people are sitting in it, scattered miles apart. If one of them stands up and tries to start the wave, nothing happens. The chain is broken. The wave dies instantly. That is the fundamental problem with space. The anatomy of the cosmic vacuum. Earth's atmosphere is incredibly dense. At sea level, there are roughly 27 quintillion molecules of gas packed into every single cubic centimeter of space. That is a mind-bogglingly crowded room, which means sound waves have absolutely no trouble finding a partner to bump into. As you travel higher, the air thins out. At the peak of Mount Everest, sound still travels, but it behaves slightly differently because the molecules are further apart. If you go past the Kármán line, the boundary of space, about 100 kilometers up the air, pressure drops to virtually zero. We often call space a vacuum, but it isn't a perfect vacuum. It is not absolutely empty. Instead, it is incredibly, unbelievably dilute. In the interstellar medium, the vast, empty space between stars, there is on average only one single atom per cubic centimeter. Let's put that into perspective. If you were to scream at the top of your lungs in deep space, the sound wave leaving your mouth would immediately fail. The physical energy of your voice would vibrate the handful of atoms directly in front of your lips, but those atoms would have to travel kilometers through the void before they accidentally collided with another atom to pass the vibration along. By the time they found another particle, the kinetic energy would have completely dissipated. The sound wave dies before it even begins. If your spacesuit helmet were to crack open in space, your final scream would never make it past your own lips. How do astronauts communicate? If space is dead silent, how do astronauts talk to each other? When Neil Armstrong and Buzz Aldrin were walking on the moon, which has virtually no atmosphere, how did they maintain a conversation? They rely on 2 primary methods, radio waves and direct physical conduction. Radio waves are not sound waves. They are a form of electromagnetic radiation, just like light, X-rays, or microwaves. Unlike mechanical sound waves, electromagnetic waves do not need a physical medium to travel. They are self-propagating ripples in the electromagnetic field, which means they can cross light years of empty space without needing a single atom to help them. When an astronaut speaks, the microphone inside their helmet captures the sound waves traveling through the pressurized air inside their suit. The radio transmitter converts those physical sound waves into electromagnetic radio waves, shoots them through the vacuum of space to their companion's receiver, and the receiver translates those signals back into physical vibrations inside the other helmet. But there is also a fascinating, low-tech hack that astronauts can use if their radios fail: helmet-to-helmet contact. If two astronauts lean in and physically press their glass visors together, they create a continuous, solid bridge of matter. When one astronaut speaks, the sound waves travel through the air in their suit, vibrate their helmet glass, which directly vibrates the second astronaut's helmet glass, which finally vibrates the air inside the second suit. It sounds metallic, muffled, and incredibly eerie, but it works, because even in the empty expanse of space, physical contact restores the medium. The haunting sounds of the cosmos. So far, we've established that space is silent, but that is actually a bit of a generalization. While most of space is a silent vacuum, there are pockets of the universe where the rules of sound still apply. You just have to look in the right places. Take galaxy clusters, for example. These are massive collections of galaxies bound together by gravity. Crucially, the space between these galaxies is not empty. It is filled with immense amounts of hot, relatively dense gas and plasma. In 2003, astronomers studying the Perseus galaxy cluster discovered something mind-blowing: acoustic waves traveling through this cosmic gas. These waves were triggered by the supermassive black hole at the center of the cluster. As the black hole pulled in matter and blasted out powerful jets of energy, it sent shockwaves, true sound waves, rippling through the surrounding gas clouds. This is a real sound wave, but with a massive catch. The frequency of this cosmic sound wave is so low that humans cannot possibly hear it. It is a B-flat, but pitched 57 octaves below middle C. To give you an idea of how deep that is, the frequency of this sound wave has a period of 10 million years. That means it takes 10 million years for a single sound wave to complete one full cycle. For comparison, the lowest frequency a healthy human ear can detect is about 20 cycles per second. NASA scientists later took the data from these acoustic waves and scaled the frequency up by 57 octaves so human ears could actually perceive it. The result is a haunting, ghostly, atmospheric groan. It sounds less like music and more like a cosmic wind machine, but it is proof that wherever there is enough matter, the universe finds a voice. Why the silence is a blessing. When we look out at the night sky, we are looking at a universe of unspeakable violence. Stars are constantly exploding, black holes are tearing matter apart at the speed of light, and entire galaxies are colliding with unimaginable force. If space did have an atmosphere, if the vacuum didn't exist, the universe would be absolutely deafening. If sound could travel through the void of space, the nuclear reactions inside our own sun would reach Earth as a constant roaring sound wall of over 100 decibels. That is as loud as standing right next to a running chainsaw or a jet engine 24 hours a day, 365 days a year, everywhere on the planet. We would live in a world of eternal, agonizing noise, and human hearing would likely never have evolved the way it did. The silence of space is not a void or a failure of physics, it is a protective shield. The cosmic vacuum ensures that the violent, chaotic symphony of the cosmos remains at a safe distance, allowing us to live in a quiet, peaceful bubble where we can enjoy the rustle of the wind, the crash of the ocean waves, and the voices of the people around us,